Hey everyone, welcome back. Today we're going to be tracking a massive, but almost entirely invisible footprint that's literally hidden right inside the walls of our homes, our roads, and our cities. I am, of course, talking about water. In this explainer, we're going to unpack the SASB sustainability standards for the construction materials industry, specifically zeroing in on how companies are required to report their water management. It's a really fascinating look at the true cost of building our modern world.
Just think about that for a second. How much water does it actually take to build an entire city? Producing cement, mixing concrete, washing aggregates, it requires absolutely staggering volumes of water. And because of this, construction materials companies face immense operational, regulatory, and reputational risks. If a company can't secure a stable water supply, production just grinds to a halt, period. If local water becomes scarce, prices skyrocket, and suddenly these giant companies find themselves competing directly with local communities just for basic survival. So this isn't just an environmental issue, right? It's a massive financial risk.
And what's really interesting is that this risk isn't just some theoretical exercise. It is totally formalized. If you dig into the SASB Sustainability Disclosure Framework for the extractive and minerals processing sector, and you scan down the list, right past greenhouse gas emissions and energy management, you're going to find our focus for today, water management. This is the official framework, specifically standard EM/CM 140A.1, that investors and regulators use to hold these companies accountable for every single drop they use.
Okay, so let's dive into exactly how this works. The SASB standard breaks this risk into a three-step reporting roadmap. First, companies have to track their total water withdrawals. Second, they have to measure exactly how much of that withdrawn water is permanently consumed. And third, and this is the real kicker, they have to assess all of this data against global baseline water stress levels. We're going to follow the journey of a drop of water through this exact roadmap to see how it plays out in the real world.
But wait, before we take that journey, we've got to get our units straight. When construction materials companies report their water usage, they are definitely not counting in gallons. They have to report in thousands of cubic meters. We're talking massive industrial-scale blocks of water. This specific metric really underscores the sheer, mind-boggling volume required just to keep a single cement plant or a quarry operational.
All right, let's hit step one of our reporting roadmap, tracking withdrawals. And let me tell you, the accounting here is absolutely unforgiving. Companies have to document the total amount of water withdrawn from literally all sources. That means every drop pumped from a local river or lake, which is surface water. It includes groundwater pulled from deep underground wells. It even includes rainwater that the facility happens to collect and store directly on site, plus the standard water piped in from municipal utilities. Basically, if it enters the facility, it gets counted in those thousands of cubic meters.
Now, the reporting structure does allow companies to break down their withdrawals by source type, which is super helpful if they're pulling from non-freshwater sources. But that raises a question. How do we officially define freshwater in this context? Well, if local laws don't set a baseline, SASB draws a hard line. Freshwater means water with less than 1,000 parts per million of dissolved solids. Oh, and a really handy rule of thumb provided by the framework: if you get the water from a municipal utility and it meets standard drinking regulations, boom, it automatically meets this freshwater threshold.
And that brings us to a really critical concept here, the difference between water withdrawn and water consumed. Think of withdrawal kind of like borrowing a book from the library. You pull the water into your facility, you use it, but you're probably going to discharge it back. Consumption, on the other hand, is like buying the book. It means you have permanently removed that water from the local ecosystem. Companies are required to report both of these numbers separately, because drawing water into a facility doesn't necessarily mean it's lost to that environment forever.
So the multi-million-dollar question is, when does that borrowed water officially become consumed water? The standard lays out three highly specific criteria. First, if the water evaporates during withdrawal, use, or discharge. Second, if the water is physically incorporated into the final product, like when it's literally mixed into a batch of cement. And third, if the water does not return to the exact same catchment area or local water basin from which it was withdrawn. If it gets piped off to a completely different region or dumped into the ocean, it is considered permanently consumed from the perspective of that specific local ecosystem.
Now, this is where things get really interesting, and the data takes a pivotal shift. Knowing exactly how much water a company withdraws and consumes in thousands of cubic meters is important, for sure. But knowing where they're using it, that is absolutely critical. Think about it. 1,000 cubic meters of water in a lush, rain-heavy region tells a very different financial and environmental story than 1,000 cubic meters in a bone-dry desert. The geographic tension changes the whole shebang.
To actually pin down and quantify this geographic risk, the framework relies on a really cool external tool, the World Resources Institute's Water Risk Atlas, which is also known as Aqueduct. Companies have to map all of their global operations against this tool to identify any activities located in dangerous, drought-prone zones. Specifically, they're looking for areas classified as having high baseline water stress, which means 40 to 80% stress, or extremely high baseline water stress, which is anything over 80%.
So once a company has mapped their facilities against the WRI Aqueduct tool, it's math time. This is where they reveal their true exposure. They take their total withdrawal and total consumption figures and cross-reference them with those stressed regions on the map. The final metric requires them to disclose the exact percentage of their total water withdrawn and the percentage of their total water consumed that occurs specifically in those high or extremely high baseline water stress locations.
So what does this all mean? Why does a simple percentage matter so much? Well, because these numbers translate directly into real-world, high-stakes business risks. If a company's data reveals that a huge chunk of its water consumption happens in extremely high-stress regions, investors immediately know that company is highly vulnerable. We're talking imminent threats of production disruptions, spiking water prices, sudden regulatory caps on usage, and intense conflict with local communities who desperately need that same scarce water. This level of transparency is just vital.
When we bring it all together for the final ledger, that standard, EMCM 148.1, really comes down to these core metrics. We've got our quantitative data, total water withdrawn and total water consumed, both officially reported in thousands of cubic meters. And right alongside that, we have the critical risk overlay, the percentage of both that withdrawal and consumption taking place in regions with high or extremely high baseline water stress. It really is a beautifully structured way to force corporate transparency around an incredibly complex global resource.
And all of this leaves us with a pretty profound question to wrap up on. As global water scarcity continues to grow, and as these exact reporting metrics expose the true environmental cost of construction, how will it change the very materials our homes, our offices, and our cities are actually made of? Will the thirsty concrete of today be replaced by some new, water-efficient innovation tomorrow? Definitely something to think about. Thanks so much for joining me on this explainer, and keep learning.